All right, pre-calc. We are starting our unit A8 on matrices today. So this first lesson is matrix algebra. We're going to do matrix addition, subtraction, multiplication, the identity, and the identity matrix. So you will be responsible for working with matrices algebraically using paper and pencil. And then you also need to be able to use your calculator. And this is going to be our trick here because I've been able to pull up a calculator before, but I no longer can do that because my trial period for it lapsed. And so I will try to explain it to you, and we'll hope that that works. So anyhow, okay, so we are going to do some things with the matrices below in the following examples. Matrix A is a 2 by 2. You always go row by column. So this is the rows, this is the column. So this would be a 2 by 2. Matrix B is also a 2 by 2. Matrix C is a 3 by 2. Up 3 over 2, and D is a 2 by 3. So example 1, the order of a matrix is indicated by the number of rows and columns. Rows times columns. A and B are 2 by 2 matrices. C is a 3 by 2, and D is a 2 by 3. Scalar multiplication. A scalar is a number that will scale all of the elements in a matrix by a factor. So, for example, here in this example 2, this first one, 3 is the scalar. So all that means is that I am multiplying the matrix A by the number 3. And so every element in 3, or in A, gets multiplied by 3. So this would be 3 times 8 is 24, 3 times negative 6 is negative 18, 3 times 7 is 21, and 3 times negative 2 is 6. All right, next, here the scalar number is 1/2. So basically what I'm doing is dividing each number by 2. So I go to matrix D, and I'm going to do 2 times 1/2 is 1, 3 times 1/2 is 3/2. I'm sorry, my dog is getting a little crazy right now. Malik, stop it. Okay, anyhow, negative 4 divided by 2 is a negative 2. 5 times 1/2 is 5/2. 1 times 1/2 is 1/2, and 0 times 1/2 is still 0. Okay, so that's multiplying by scalars. Example 3, adding or subtracting matrices can only be done on matrices with the exact same dimensions. Okay, so for example here, I want to do A, matrix A minus 2 times matrix B. Well, in order to subtract, A has to be the same dimensions as B, which they are. They're both 2 by 2. So I can do this. So I would do, A is 8, negative 6, 7, negative 2, minus, I'm going to multiply B by 2. So I have negative 6, 8, 2, 4. And so now I'm going to subtract. And my final answer will be 8. I subtract each coordinating number. So this one, 8 minus a negative 6 would be 14. Negative 6 minus 8 would be negative 14. 7 minus 2 would be 5. And negative 2 minus 4 would be a negative 6. And there's your answer. So 2A plus 3C. A is a 2 by 2, but C is a 3 by 2. They are not the same dimension, so this is not possible. because A is a 2 by 2 and C is a 3 by 2. You cannot add or subtract them unless they have the exact same dimensions. Is matrix addition commutative? The answer to that is yes. Matrix addition. So that's saying matrix A plus matrix B would be the same as matrix B plus matrix A. And so that's what commutative means. They move around, and the answer is yes, it's commutative. And that's pretty important because we're going to get to multiplication next. But addition is commutative. All right, multiplying matrices requires that the number of columns in the first matrix be equal to the number of rows in the second matrix. The solution of matrix multiplication will have the outer dimensions of the matrices being multiplied. So, this is going to be tricky because I can't even see them. I'm going to have to write that here. Okay, so matrix A is 8, 7, -6, -2. And matrix B, I'm just copying from the top of the page so I can see it, -3, 1, 4, 2. That just comes from right up here. We're using these same matrices, okay? All right, I hope I copied them right. -3, 4, 1, 2. Okay, so if I'm going to multiply these, the first thing you want to do is you want to say, can we multiply it? And if we can, then what will be the dimensions of your answer? All right, so the A matrix is a 2 by 2. The B matrix is also a 2 by 2. So here's the rule. In order to multiply, these two numbers must be the same. Whoa. All right. So those have to be the same. And yes, they are the same. And then once you verify that those two numbers are the same, then the outer two numbers are the dimensions of your product. So when you multiply a 2 by 2 and a 2 by 2, you are going to get a 2 by 2. And so you need to know that because when you multiply these matrices, and you will have to do this without a calculator. I mean, you can do it with a calculator sometimes, but these will be non-calculator problems on your test. So this is how you multiply them. All right, you're going to write your matrix, and, oh my goodness, do you hear my dog? All right, are you about done there, Malik? Okay, you are going to take, let me see how I can do this for you. It's really fun since we are doing this online. You are going to take the top row times the first column. So 8 times -3 plus -6 times 1. And that will give me my first number in my new product matrix. And then I'm going to do the top row times the second column. So -8, or I'm sorry, that's a +8, I think. Yeah. 8 times 4 plus -6 times 2. All right. And now we're going to do the second row times the first column. So 7 times -3, -2 times 1. And then finally, we do the second row times the second column. So that would be 7 times 4 plus -2 times 2. And there's the end of the matrix. And so now you solve that. -24 minus 6 is -30. 32 minus 12 is 20. -21 minus 2 is -23. And 28 minus 4 is 24. And there's your answer. And notice this answer is a 2 by 2 matrix. All right? So that's kind of fun. So now we'll do the next one. All right, so we have B times A. So notice this was A times B. That's the order there. Here we're switching the order. And so I'm going to write them in that order. So I'm doing B first times A. 8, negative 6, 7, negative 2. All right, so I already know this is a 2 by 2, this is a 2 by 2. When I multiply them, I will get another 2 by 2. So I'm going to do, let me get my colors going again. All right, top row, first column. So negative 3 times 8 plus negative 4 times 7. Okay. Next one, top row, second column. Negative 3 times negative 6 plus 4 times negative 2. Okay. Second row, first column. 1 times 8 plus 2 times 7. And then finally we have another color. I already used that color. I'll use that color. Okay. And now we have second row. Well, you can't even see that color. I have to change that. I can't see it. Maybe you can see it. You guys all have young eyes. All right. There we go. So I have 1 times negative 6 plus 2 times negative 2. So then what do I get? Negative 24 plus 28 gives me a 4. 18 minus 8 gives me a 10. 8 plus 14 gives me a 22. And negative 6 minus 4 gives me a negative 10. And so right there you can see that matrix multiplication is not commutative. The order changes it. So if I do A times B, I land up with this matrix. If I do B times A, I land up with this matrix. And so that is a question down here. Is matrix multiplication commutative? The answer is no. All right, but let's continue on here. I am going to delete a whole bunch of this here because I don't have space. So I should have background music for you guys while I do this, but I'm not going to. Okay, here we go. So we're going to draw again. All right, so this time we have A and D. So the first thing you want to check is if it's possible. So A, as we know, is a 2 by 2. And D, looking at the top, is a 2 by 3. And so remember, well, let me write those down first. A is going to be 8, negative 6, 7, negative 2. And D is the matrix. By the way, we use these capital letters for our matrices. We have 2, 5, 3, 1, negative 4, 0. Okay. So when I multiply these, remember these two have to be the same. And yes, they are, so I can multiply. Then these outer ones tell me that I will have a 2 by 3 as my answer. And so as you get into different dimensions being multiplied, it's always good to know what you're trying to get. You're trying to get a 2 by 3. All right? And so now here we go. We're going to do top row, first column. So I have 8 times 2 plus negative 6 times 5. Okay? And then I'm going to do top row times second column. So I have 8 times 3 plus negative 6 times 1. And now I need to do the top row again times the third column, which is 8 times 4. Oh boy. 8 times negative 4 plus negative 6 times 0. All right, so I'm putting a little line in there so we remember where that belongs. Okay, and now I do the second row times the first column. 7 times 2 plus negative 2 times 5. Second row times the second column. 7 times 3 plus negative 2 times 1. Second row times the third column. 7 times negative 4 plus negative 2 times 0. And there's the end of my matrix. And now I clean it up. And I should have 16 minus 30 is a negative 14. 24 minus 6 is a 18. Negative 32 plus 0 is negative 32. 14 minus 10 is negative 4. I'm sorry, 14 minus 10 is positive 4. 21 minus 2 is 19. And then finally, negative 28 plus 0 is negative 28. And there you go. Okay. So then finally, it's saying, what about C times D? And I'm just going to write, oh, yeah, I need more space for that too. So I'm erasing this. You can always go back if you need to see it. Okay. So while I do this, why don't you decide first if the matrix multiplication is possible, and if so, what the dimensions will be while I get my information written down. C is 2, 3, 1, 4, negative 1, negative 2. And D is 2, 3, negative 4, 5, 1, 0. And I know I already had D here, but I like to write it in the right order that I'm multiplying so I do not get lost. You can get lost on these, so just, be aware. Okay, so C is a 3 by 2. D is a 2 by 3. These numbers are the same, so yes, you can multiply. These numbers give me the dimensions of the product. So I'm going to get a 3 by 3. All right, so I'm going to do first row, first column. 2 times 2 plus 3 times 5. First row, second column. 2 times 3 plus 3 times 1. First row, third column. 2 times a negative 4 plus 3 times 0. All right, next one. Second row times first column. 1 times 2 plus 4 times 5. Second row, second column. 1 times 3 plus 4 times 1. And then finally, 1 times negative 4 plus 4 times 0. And then finally, third row, negative 1 times 2 plus negative 2 times 5. All right, second column, negative 1 times 3 plus negative 2 times 1. And then finally, negative 1 times negative 4 plus negative 2 times 0. So I clean that up. Can make that a little bigger. All right, so I have 4 plus 15 makes 19. 6 plus 3 makes 9. Negative 8 plus 0 makes negative 8. 2 plus 20 makes 22. 3 plus 4 makes 7. Negative 4 plus 0 makes negative 4. Negative 2 and negative 10 make negative 12. Negative 3 and negative 2 make negative 5. And then finally, positive 4. And there you go. And there you have matrix multiplication. All right, now we're going to get to the identity matrix. The n by n identity matrix. So right there, when it says n by n, it's telling you the dimensions are the same. This has to be a square matrix. All right, you can only have an identity matrix that is a square matrix. So the n by n identity matrix, denoted as IN, is a matrix with n rows and n columns. The entries on the diagonal from the upper left to the bottom right are all ones, and all other entries are 0. Remember the multiplicative identity and the additive identity. So let's just talk about that really quick. What is the multiplicative? I'm totally saying that awkwardly, but that's just the way it is today. And always, really. All right, so if I want to multiply and get the same number, well then we know that the identity for multiplication is 1, because I know A times 1 equals A. So this is the identity for multiplication. What's the additive identity? 0. A plus 0 gives me A. And there it is. That's the additive identity. And so we also have identities for matrices. So the identity for a 2 by 2 would be a 1, 0, 0, 1. You need those ones in a diagonal. An identity for a 3 by 3 would be 1, 1, 1, and everything else is a 0. Okay? So, and it's the same idea for these identity matrices. So let A be this matrix, let B be this one, let C be this one. Consider the 2 by 2 identity matrix right there. Find A1, B1, and C1 using your calculator. What do you notice? So right there, we're going to take out our graphing calculators. And there's a couple things you need to know. So first of all, the official way to do matrices would be to hit your second function, and then hit your x to the negative 1 button, which is down below, like 4 down. It has the word matrix written above it. Okay, hit that. Of course, I didn't, so let me try it again. All right, and now what you have is names, math, and edit. All right, names, you know, you can see that that's just the name of the matrix. So math, these are different things you can do with your matrix. And then edit would be how you would put in your matrix. And so move your cursor over to edit, and let's edit matrix A. So put your cursor on edit, hit enter, and now I don't know what you're looking at, but I'm currently looking at a 3 by 3 matrix. But if I want to put, like I'm looking at my notes here, I want to put A in as a 2 by 2, then the first thing I want to do is I want to change the 3's to 2, and I want to get a 2 by 2 matrix in. And when you hit 2 by 2 in that line, you should get a 2 by 2 matrix. And then you enter your values for your matrix A, which is 1. Hit enter after each entry, and it just moves you to the next spot. 1, 3, 2, 5. And once you hit enter, you should have matrix A as a 2 by 2 with 1, 3, 2, 5 as its elements. And then hit second quit. And it clears it out, but it's saved. So now if you hit that second matrix again, and you hit, and now you're under names, and you hit enter. No, I didn't want you to do that. Hit second matrix and go to edit, and when you hit enter, you'll see that it has stored your matrix in there. Okay? So that is one way you can go and put all your matrices into your calculator and do things with them. But there's another way, and that is hitting alpha zoom. So hit quit, clear everything, hit alpha zoom. And what pops up is a little blue screen, and you see the rows and the columns, and it defaults to a 2 by 2. But if you want to change it, you use your little arrows, and you can go through and make it like a 3 by 3 or a 4 by 4. But let's just leave it as a 2 by 2. Hit OK, so you should be on OK automatically. Hit Enter, and there's your little 2 by 2 matrix on your screen. And so then you can put in those numbers. And so what I want you to do, we're not going to do all of these because, you know, time is worth something. But what I want you to do now is I want you to clear your screen or quit or whatever you want to do. All right. And so go in to second matrix. You should have already stored matrix A in the A spot. So now I want you to go to Edit, and I want you to store another 2 by 2 in the B spot. And so you go, move over to Edit, move your cursor down to B, and hit Enter. Make sure it's a 2 by 2 again. And now put in your identity matrix in the B spot. And so you have a 1, 0, 0, 1. All right, second quit. And now multiply those. So that means you would do second matrix, and just do the name here, A, times second matrix B, which is my identity matrix. And when you do that, you should get your A matrix again, which is 1, 3, 2, 5. So when you multiply a matrix by the identity matrix, you get the original matrix again. The same would be true for B times the identity and C times the identity. And then step 2, if you go the other direction, the identity times A, the identity times B, the identity times A, you get the exact same thing. So although matrix multiplication is not commutative, when you're using the identity matrix, it is. So we are just going to move on from there. The product of any square matrix and the appropriate identity matrix is always the original matrix, regardless of the order in which the multiplication was performed. In other words, this is what you need to know. A times the identity is the same as the identity times A, and they all equal A. Okay, inverse matrix. The inverse of a square matrix, A, is sometimes called a reciprocal matrix. We use A to the -1, but we read it as inverse matrix A. Okay, it's not an exponent. We've run into that before with functions, such that the matrix times its inverse will give you the identity, which is the same as like if we did the number 4 times the inverse of 4. What does that give me? The multiplicative identity 1. And that's what we're doing here. So let D be 7, 4, 5, 3. The inverse of D is 3, 7, -5, -4. Now, you're just going to have to trust us on that until the next lesson. In the next lesson, you'll learn how to find the inverse. But for now, this is just, we're telling you, this is the inverse. Okay, you guys. I've had a little technical difficulty. I'm hoping that I'm picking up at the right spot. I think you can see how far we've gone with all this. I just need to erase it all. Hold on. In fact, okay, so I believe that we've covered the inverses. If you multiply the matrix times its inverse, you should get the identity. And so it's saying you could go into your calculator, you can put D in right there, 7, 5, 4, 3. You could put the inverse matrix of D in, 3, -5, -4, 7, and you multiply those together and you will get the identity matrix. And it does not matter which order you do it, you will still get the identity matrix. So we are at step 4, and the question is, use matrix multiplication by hand to decide which of the following is the inverse of matrix A in step A. in step 1. And so what we're saying is this the inverse? Is this the inverse or is this the inverse? How can we tell? Well, does AF equal the identity? Or does AG equal the identity? Or does AH equal the identity? That's the question. If A, and I believe this is A, which I wrote down earlier, if A is 1, 3, 2, 5, and I multiply it by F, I should get my identity matrix. If it's the inverse. If I don't get the identity matrix, then it's not the inverse. So let's just do that real quick. Let's see what AF is. So you're going to go top row times first column. So 1 times 5 is 5 plus 3 times negative 2 is a negative 6. And then you're going to do top row times second column. So 1 times negative 3 is negative 3, and 3 times 1 is 3. Truthfully, I could stop right there though, because this will give me a 0, which I need. Remember your identity matrix is this, 1, 0, 0, 1. And this gives me a 0, check, but this will give me a negative 1, not a positive 1. So no, this is not the inverse. So now I'll try AG. So now I'm going to take my A times my G. So the top row, 1 times negative 5 is a negative 5, and 3 times 2 is 6. So that will give me a positive 1. And now I do 1 times 3 is 3, and 3 times negative 1 is a negative 3, and that will give me a 0. So that's good. Now I'll do the second row times the first column. So 2 times negative 5 makes a negative 10, and 5 times 2 makes a positive 10, so that gives me a 0. And then finally, 2 times 3 makes a 6, and 5 times a negative 1 makes a negative 5. And so this cleaned up is 1, 0, 0, 1. And so therefore, this is the inverse matrix to matrix A. This one, well, I mean, you already know this is the inverse, so this one can't be the inverse. But when you multiply them, the first number you're going to get is an 8. And therefore, right away, you know that won't be the inverse. Okay? Drawing conclusions. For any 2 by 2 matrix, what is true of the products of A times the identity and the identity times A, where I, which is the identity, is the 2 by 2 identity matrix. So what do we know about that? We know that A times the identity is the same as the identity times A, and both of them will equal the A matrix. Next, what is the multiplicative identity? 1. We talked about that. A times the number 1 is A. How is the relationship between the identity matrix and other 2 by 2 matrices similar to the relationship between the multiplicative identity and other real numbers? Well, when you multiply by 1, you get the original number. And when you multiply by the identity matrix, you will also get the original matrix. 3. What is the identity matrix for the set of 3 by 3 matrices? So that would be 1, 1, 1. 0, 0, 0, 0, 0, 0. There's your identity matrix. And then it says check your answer by multiplying your proposed identity matrix by a 3 by 3 matrix. I will leave that to you to do because this video is getting very long. Step number 4. What is the relationship between a matrix, its inverse, and the identity matrix? So let's say the matrix, we'll call it A. The inverse would be the inverse of A, and you multiply those and you get the identity matrix. That's the relationship. How is this relationship like any found in the real number system? You could say a real number times the reciprocal of the real number equals 1. How's that? 5. Does every non-zero matrix have an inverse? No. Explain. All All right, here, 1, 2, 0, 0. That matrix, there is nothing you can multiply it by in order to get 1, 0, 0, 1. Okay, because no matter what you do, you cannot create a 1 down here. It will be impossible. I'll leave that to you to try. So anyhow, not every matrix has an inverse. Finally, find the inverse of F by finding the values of A, B, C, and D such that that equation is true. So that one I want to do because that might show up for you. So we want to say, so here's F, right? Here would be the inverse of F, and here's the identity. And we know that the matrix times its inverse will give you the identity. So let's set up the multiplication. All right, so we're going to say, top row, first column, 2 times A plus 7 times C. And then the next one, 2 times B plus 7 times D. Second row, first column, 1 times A plus 4 times C. And then the second row, second column, 1 times B plus 4 times D. So all I did was perform the multiplication of these two matrices, writing it there, and that would have to equal 1, 0, 0, 1, right? So that means 2A plus 7C has to equal 1. And 1A plus 4C has to equal 0. And then over here, 2B plus 7D has to equal 0. And 1B plus 4D has to equal 1. So we have two different systems of two equations. And so you guys remember how to do that. I should have left a little more room here. I'm going to rewrite this. 2B plus 7D equals 0. 1B plus 4D equals 1. Erase this so I have some space to work. You guys remember elimination? I'm getting sick of that pinky color, so here we go. Okay, I'm going to multiply this second equation by a -2. And so then I have 2A plus 7C equals 1. And this would be -2A minus 8C equals 0. Add them up, and the 2A's cancel. 7 minus 8 is a -C equals 1. And so C is a -1. And I have one of my numbers. All right, once I know one of those, I can put it in there. I'll just put it into the bottom one. So 1A plus 4 times a -1 equals 0. So A equals 4. And there's another number. All right, now over here, I'll multiply this equation by a -2. And so I have 2B plus 7D equals 0. Here I have -2B minus 8D equals -2. Add those up, the B's cancel. 7 minus 8 is a -1. D equals a -2, so therefore D is 2. And then I need to find B, so I'm going to plug that in. So B plus 4 times 2 is 1. So B is 1 minus 8, which is a -7. So now I can find this right here. That was my whole goal, to find the inverse. And that would be A is 4, B is -7, C is -1, and D is 2. There's the inverse. Now the good news is there's a better way to do that. But that is one way to do it. And I also wanted to do that because you need to see how you can take that and write these little equations. You're going to be doing that. So you want to be able to find your information. And that is the end of the lesson.